a series of questions that I circulated ahead of time. And I think the first one is to define the terms of the conversation. So we're talking about mathematics in the curriculum. What mathematics are we talking about? Are we talking about algebra? Are we talking about calculus? Both? And not only which kind of math, but why, right? So let's see where we stand on this topic of what kind of math.
Okay, so the distinctions I draw are, I try and use as little math as I can, just to start with all of that. So math is a language, and we're an incredibly unusual tribe. We're probably the only tribe of people who use math as a language when we're uncomfortable. We use it when we're uncomfortable with English. We revert back to the math because we've spent time in graduate school becoming comfortable in that language. That's completely different than any other human being on Earth. Most human beings find math deeply uncomfortable. And so the idea that we'd revert back to it when we're uncomfortable is quite unusual. And so, you know, my great passion in all of this is I love economics, and I don't want a language problem to get in the way. So I want to speak the language that's most likely to be received by others. So in terms of sort of defining where we're at, I'm going to try and use English as much as I can side of things rather than math. Now to answer Diego's excellent question, what does that mean? There are some parts of math that are unavoidable, but I think they're smaller than most of us admit. So when we teach supply and demand, we teach it using a diagram, the big X, right? So that's an analytic chart. It's at the heart of so much economics that I don't see a way of doing economics without it. That I need and I use. Do I need algebra? So my basic rule of thumb with all of this is I'm not going to teach a freshman a skill that I have never been required to use in 20 years as a professional economist. So in 20 years as a professional economist, no one has ever given me the equation for a demand curve, the equation for a supply curve, and told me to solve the series of simultaneous equations for P and Q. In 20 years as an economist, no one has ever asked me to measure the elasticity using the midpoint formula. It's not something economists do. It's something we teach, but we don't do. So that's my basic rule of thumb. So that means that allows me to avoid a lot of algebra, avoid almost to the point of eliminate. And because I've never been asked to solve for, you know, if P equals 3 and the demand curve has a slope of -2, you know, what's the equilibrium? Again, that's not something I've ever done as a professional economist, so I avoid plug and chug. The answer to a question should never be 4, because it's rare that we actually face questions that we can answer with that sort of precision. There is one other form of math that I think is increasingly important, which is our students are growing up amongst a tidal wave of information, and being able to represent that information, statistical information, compactly, so this is statistical charts, infographics, and the like, is, I think, an incredibly important skill. And so this is where economics has become empirical, and so the empiricist's version of a supply and demand curve is, you know, a time series chart, and it's other interesting ways of representing data. And I think we have to introduce them to that, help them through that, and hopefully help them develop some fluency in that.
I think all of us could teach a course for principles of economics that is entirely just informative, that is entirely intuitive, giving wonderful examples. I think students would enjoy it greatly, and I think they would get great intuition from it. We could pick wonderful examples from newspapers or, you know, current events, etc. I have no doubt that we could all, each of us, teach a fantastic course without the math. I have no doubt about it. But I think we want to do more. I think one of the things that we want to show students is the mathematical underpinnings of that intuition. Why is it important? It's important because it just adds another aspect to what they're learning. It gives them the technical structure that underlies what they're looking at. It allows them to come up with examples and counterexamples of the concepts for themselves. And it provides a way of thinking about the problem that is very different. So if I go into class and I present a beautiful example of topics, let me just give 2 examples. Let's say we're talking about something like, when price goes up, total revenue may go up or may go down. And I could explain that, and I may do a very good job of explaining it, and they may get it when I explain it, just verbally. But on the other hand, if I were to show them a couple of numerical examples, or if I showed them a graph, that would just make it so much more clear. So what the mathematics lens, and I'll get back to you on what I mean by mathematics. What the mathematics lends to the learning is a little bit of depth and clarity to the intuition that we're giving them. The other example that we were talking about in my group last night, when Eric threw out the question at the end of the sessions, he asked about, what did you pick up during the day? And at my table, we came up with the question, what about tax incidence and tax imposition? We all agreed that that is such a difficult concept to teach. As fine as teachers as we may be, that question, how do you explain to students that, no matter who the tax is imposed on, whether it's imposed on sellers or buyers, that the incidence of the tax is going to be the same, that is very difficult to explain to students. Again, we could try explaining it intuitively, but again, giving them a couple of mathematical examples or showing them a graph really clarifies the issue. Why else do we want to integrate the math? Several people said things yesterday that really hit home to me. David, when he was talked about misconceptions that people have, and often those misconceptions are because of lack of mathematical understanding. So economics, whether you like it or not, is a subject that's based in mathematics. The ideas are mathematical. Think about comparative advantage, for example. And so if somebody doesn't understand how ratios work or proportions work, which is what we see in the classroom, then they're not going to get it as much as we might try and explain it to them. The second issue that I want to point out, so when we talk to students about, why do you need to have math in the classroom? And by the way, by math, again, let me clarify, what I mean is basic arithmetic, basic algebra, basic geometry, and drawing some linear graphs. That's it. So I'm talking about Algebra 1 level mathematics. I'm not talking about calculus. I'm not even talking about Algebra 2. Basic math that they need to understand an article in the newspaper, to be able to follow one of your tweets, Justin. This is just the basic math that you need for everyday life, for financial literacy, et cetera. And as economists, I feel like it's really important. The other thing I want to go back to is what Claire Batista pointed out in her slides yesterday. No matter what, when it comes to math, it's women. Women are the ones who are not confident about their ability. And so whatever we can do to help them with the math, if we send them out there being better versed in math, then it's going to help them with better job opportunities, et cetera, et cetera. We're going to have a group of people this afternoon talking about women's empowerment, and I believe that the mathematics is one way to that.
All right. Thank you. Alex?
So my feeling, math and principles, I think of the average principles class, and it's large, diverse, and it's full of non-econ majors. And we have a really short time to kind of get that intuition across. And our goal for most of us is to get them to think like an economist on a few issues. And that's a tall order. We don't have much time. When you think of it that way, I think math and economic intuition are kind of substitutes. If we focus more on math, that's crowding out time, examples, applications where we can build up that intuition. So I think that's one problem. As principles are taught right now, we don't have much time to get all the points across, all the intuition across. Another thing I find is in these large, diverse classes is math is really polarizing, the way people feel about it. And like Irene said, I agree, it's a misconception. For a lot of students, it's not true, but a lot of students feel they're weak at math or they don't get math. So that's a big barrier for students. Makes our classes less inclusive, I believe. And another problem, I think, the funny thing is when I do introduce math, or I've experimented with my principles class to put the equations in, and again, it's polarized, so you have students very comfortable with math, students that aren't comfortable with math. The ones that are comfortable with math look at our really simple equations, because math isn't that tough, and they think, this is a joke, this class is easy, I'm not going to study for the midterm. So you kind of skip over like the intuition, the deeper understanding. The other students that are afraid of math, they get really intimidated and think, wow, math is just quantitative. It's not for me, or I'll never get it. So I feel in a lot of ways it can be a barrier. And I think another problem when we think about math and economics, when we try to relate to our students, we think about our own experience. I think about, I didn't really get marginal concepts until I realized you could just take with a derivative, or I didn't understand profit maximization until I could do it with an optimization program. And that's not a great place to think from. That's not our average student, especially considering they're not econ majors. So I think we should keep math, as much math out of there as possible. So definitely not calculus, real algebra. I think for now I just really do with percentage growth. That's about as far as math goes in my class now.
All right.
Do you want to create some conflict now?
I think it's brewing. What do you have in mind?
So I wanted to come. Well, it's up to you if you want to go there.
Yes,
but,
yes, go there.
Let me just say something, because you brought this issue of so the language of math as formal reasoning, right? So math is an embodiment of logic. We can make a very complex argument by using formulas and symbolic logic, and that's why we use math in economics, right? But you also brought the issue of quantitative reasoning, proportions. Alex also talked about, reading graphs, and there are different kinds of math thinking, right? So numeracy, the skill,
Yes.
the ability to read numbers, is broader than what mathematicians teach, and is broader than what we use in graduate school. So I think I think there's conflict in where we place ourselves in that spectrum of numeracy skills, but please go ahead.
So I wanted to come back. I want to tell a story. So Irene said, one of the important reasons we need math is it's the only way to teach tax incidence, the invariance of tax incidence.
Not the only way.
Well, you said it was a compelling way. So I want to tell you a story about an economist I know. He went through 4 years at a university, it was actually the University of Sydney. Never understood this concept once. Went off to the United States to get his PhD. Met a beautiful woman, Betsy Stevenson. This economist is me. Went through the microsequence, still didn't quite understand it. I knew how to parrot it back on an exam, but every time I was asked about this thing, I was like, it's this magic thing, there's graphs. But I still don't get it.
Yeah.
Every time, for years, Betsy would tease me in front of other economists. I'm the only moron who didn't understand this at a deeper intuitive level. And I was at dinner with my colleague Joel Slemrod, and he explained it to me without an ounce of math, and I've understood it ever since. And this is how I teach it. So what I do, I need an assistant. Can someone be an assistant right now? Who wants to be a student? Diego, come on up, man. So you're my student. And so the example I use when I teach this is we're doing a cigarette tax. Cigarettes cost $4, and we're thinking about adding a tax of $3, right? And so you're going to be the shopkeeper, and I'm going to walk into your shop, okay? We're going to start off with, it's a tax, and on the counter, let's make it physical, there's a jar, right? Irene, you hold that. You're the tax man. There's a jar on the counter for putting taxes in. Let's now act out what a tax on buyers looks like. Diego, I'd like a packet of cigarettes.
Yes, sir. It will be $5 plus tax.
Great. So I'm going to pull out my $5 right now, and then I'm going to pull out the extra $3 of tax. So I'm going to give Diego $5. That's what he's charging me. And I have to put $3 in the jar. Diego, you want to put that money in the cash register now, right? What are you going to put in the... Great. What just happened? I took $8 out of my pocket, $3 went in the jar, $5 in Diego's pocket. Let's act it out again. I want to make it a tax on sellers. Diego, I'd like a packet of cigarettes.
It will be $5 plus tax.
Okay, here's $8, Diego.
This is 5 for me, and 3 for the jar.
What just happened? $8 came out of my wallet. $5 went in his pocket, 3 went in the jar. Happened both ways. There was no math at all. So that's how I teach this.
You can applaud that.
Here's your glass back.
The point is, I've done the graphs, I've taught the graphs, I've done the algebra, I've taught the algebra. Honestly, it was 7 years of my career as an economist never understanding it, and I now understand it, and it had nothing to do with math. And it was about, and I think this is Alex's point, let's get to the underlying intuition of it, and it was that jar on the counter that made me finally understand it. It didn't matter who was putting the money in as long as the money was going in.
Now, may I respond? So
By direct,
I love the example. I love the example. I think students would love it. And I agree with you that often, those of us, even with PhDs, often don't understand at an intuitive level many of the very important concepts. I have a bunch of teaching assistants who work with me for the principal's classes, and I force them to come to class to sit in the lecture. I've always felt very guilty about doing that, but on the other hand, I feel like I want them to know what I'm teaching so that they can talk to students later in discussion sections. You know, if a student says, well, what did she mean when she said that? Then they will know because they have been there. But I've always felt guilty about asking them to give up their time to come there. But a couple of graduate students have told me that coming to the class has been so helpful. It actually helped them on their, comps or something. Something that we did in the principal's class actually helped them answer a question on the comps. So then I realized, oh my gosh, somewhere along the way, with all the math, we lose our intuition. And then we're not quite understanding exactly what we're doing. So I'm completely in agreement with you on that. I do believe that the basis for what we're teaching them is intuition. There's no doubt about it. Without the intuition, the math is useless. But my argument is that in addition to the intuition, we've got to give our students, even at the principal's level, some basic understanding of the mathematical underpinnings of what they're studying. Your example was a great example for somebody who might learn, kinesthetically, right? But on the other hand, there are other students who learn very differently. They like reading, or they learn by looking at a graph. And so having the different tools to use when they're learning, and some of them may be good at algebra, and maybe the algebra will help them or clarify the concept better. So I think we have to have, that's the beauty of the subject, is that we can show them different ways of looking at the same concept verbally, intuitively, a beautiful demonstration, or a beautiful little graph, or a nice equation. So we have all these different ways of showing it to them. I want to go back to what you said, Alex, about not having time in the classroom. I agree with that completely. The difficulty, I think, and I think the challenge for us, I think overall, most of us here in the room would rather have a student walking into a Principles of Economics class, knowing the basic math, Algebra 1, having mastered it, than not. It would make our lives a lot easier. We would then know that we were teaching the students what they needed to know. I mean, if you really felt like the math was completely useless, that would be a choice, but then not because the students didn't know the math. And that's fine in that case. But the issue shouldn't be that we're not teaching it because the students don't know the math. And so, so the question is then, okay, if we do want the students coming into class prepared, and if we don't have time in the classroom, in the Principles of Economics classroom, when do we teach it? And my answer is that I have an answer, and I'd be happy to talk more about it, but perhaps it has to come before the Principles of Economics class. There has to be some way. I teach a class that's about, every semester I have something like 900 students in a class, and they are from all over the university. About 40% of my class is from the International Affairs School. All they have to do is take the introductory classes and nothing more. I've got another 1/3 of my class, which is coming from the business school. All they have to do is take the introductory classes and nothing more. And just another 1/3 is coming from CCAS, who might go on to become econ majors. So those guys, will may never end up doing calculus or anything. But how do I teach all the different groups to ensure that I'm getting the guys who are going to be econ majors ready for the econ major, and also making sure that I'm, treating the others in the classroom fairly, not unnecessarily giving them more math than they need, but making sure they know enough math that if they're going to go into security analysis, or if they're going to go into foreign policy, that they understand, game theory, because that's a class they might want to take. For heaven's sake, it's very relevant. Or somebody in the business school who decides they want to go into finance has the mathematical background to be able to go into it and think mathematically.
Let me redirect before we start getting too much agreement, because we all start drifting towards, I see your point, yes, no. So let's see if we can spread the positions a little bit. One thing that we all gone to graduate school, so we do a lot of math. To what degree is fair to expose students to economics, introduction to economics? This is the discipline, and teach the class with cartoons and beautiful, colorful examples. If the discipline itself is going to be heavily formalized and is going to make intensive use of math, so think about the gap between introduction to economics and the next intermediate theory class, intermediate macro or intermediate micro. Are we servicing our students, all of them, the majority of them? Are we disservicing them by presenting the discipline in a very non-formal way?
Maybe.
Let's start with Alex.
Yeah, that's a really good question. And I think that's So again, I don't think we should use as little math in principles as possible. But I think that's one of the strongest arguments to actually put math in principles is I get so many students, they take principles, my principles class, and because I'm so charismatic and knowledgeable, they take an econ major. That doesn't have that much. But the ones that do, they'll come to my office a couple years later and they said, you know, I loved economics in your class, and then I got second or third year and there's calculus and math and econometrics, and I don't like it now and I'm struggling. So that's one really good point I find. We do mislead students a bit in principles if we don't include much math. But then, I don't know, to give them an idea of how much math there is in a senior undergraduate course or graduate course, it'd be impossible to include that all or get the point across. And is it that big a problem considering most of our students, in my school anyways, aren't econ majors? I guess it's not that big a problem because most aren't going on to an undergraduate degree in econ. And even those that do major in economics at undergraduate level, maybe 5% go on to graduate school, so maybe it's not that big a problem. I don't know.
So where do you fall on that one, Justin? Are you on Alex's side or?
So I want to make 3 points. I think the first answer, ironically, is it's really about the math, which is last time I saw the numbers, there's 1 million kids a year taking principles and 100,000 who take an intermediate course, and an even smaller proportion that go on to become a major. If I'm thinking about teaching 1 million kids or 100,000, 1 million's bigger than 100,000, so I think we should focus on the 1 million. And it's not great for the 10% who are going on, but what we're going to do is we're going to arouse their passions, get them interested, fire them up with a set of intuitions for when in intermediate they start learning formal tools. And then when they're in intermediate learning the formal tools, they'll have the intuitions we gave them, and so the formal stuff will also be right. So, for me, it's really, who am I teaching? And it's going to vary for each of us in our classrooms. Some of you may have more majors than I do, but I'm roughly around about the 10% mark in my classrooms. The second point is, in many cases, and I'm struck by this, students don't know enough math for us to teach them economics using math. And I don't have enough time to undo the sins of the American school system. That's a totally sincere statement. That wasn't a joke. I have students who really, really struggle with a bunch of things, and I'm going to teach them economics because that's what I believe in, and it's the only thing I know how to do. The third thing is, Irene, now we're going to be closer. Do the math, but do it in English. Let me explain what I mean by that. So a question for a small business owner is, how many workers should I hire? Well, I could set up the profit function and take a first derivative, examine the first order condition, and discover that wage equals marginal revenue product. Or I could say in English, should I hire one more worker? What's the benefit of hiring one more worker? I'll get a bit more revenue. What's the word we use for that? Marginal revenue product. What's the cost of that? I'm going to have to pay him a wage. Should I hire one more worker? It depends on the balance between the marginal revenue product and the wage. That's the math, but it's in English. And because they don't speak the language that is math, they might be able to follow the formal structure when we speak in a language that they're familiar with.
Irene?
So a couple of my TAs one year came up to me and said, Professor Foster, you've got to go on Rate My Professor and look at your ratings. And I said, I don't want to do that. I don't like doing that, because it's either the guys who absolutely love you or the guys who absolutely hate you who put stuff about you on Rate My Professor. So I said, I'd much rather look at course evaluations than look at that. And the student kept insisting, so I said, okay, what the heck? And I went on there and looked at it, and this was the first rating that I saw. It said, Foster is the devil of economics. It's true. This is absolutely true. Foster is the devil of economics. She makes this class much harder than it needs to be. Don't take it with her. And don't was in all caps. Don't take it with her. So that, and I thought to myself, yes, I was absolutely right. I shouldn't have gone there and looked at it. So, but it really struck me that, not the devil of economics part, the fact that the student said that she makes the class much harder than it needs to be. And I thought to myself, I've been teaching this stuff for a long time, I have a sense, I think I have a very good sense. I come to conferences like this and meet you fine people, and I know what you teach in your classes, and that's part of what informs what I teach in my class. How does a freshman know that this class is too hard and much harder than it needs to be? So I thought to myself, there's a real difference between my expectations of what the class should be and obviously their expectations of what the class should be. And so I thought, maybe I'm not making it clear in class. And so ever since I saw that, on the first day of class, I actually always show them that slide. I show them the quote, they get a big kick out of it. And then I talk about my expectations for the class. And I tell them, why is the class this way? Why do I expect you to know this math? Why are we testing? In fact, at GW, what we do is the very first week of classes, we do a math assessment to see where students stand in terms of the mathematics. And I tell them that the reason we're doing this is, one, because we want you to be prepared for the upper level classes. I know my colleagues who are teaching intermediate micro and macro or development economics are going to expect certain skills of you, and so we want to make sure that you are prepared for it. Even those of you who may not think at this point that you want to be an econ major, we will have you prepared for it in case you decide you do want to be an econ major. Then the second reason is we know that those of you who have the mathematical and statistical skills that you referred to will have better job options at the end of 4 years when you graduate from here. And again, this is going back to what Claire said yesterday, something about higher returns to analytical skills. That's what we're seeing. And you look at any listing that it'll tell you that the jobs that are out there that pay better are requiring students to have mathematical and statistical skills. And then women. We find that when we test women, when we educate them, when we give them the math preparation, we find more students actually go into economics. And if there was anything that I think is a big problem in economic education, it's the math preparation of the students coming in. And the second issue, the second problem that we have that follows from that is fewer women in math. The numbers that you guys threw around, the million students, over 1 million students taking principles of economics, and then only 100,000 going into economics as a major, I think is because of math preparation. They're scared of the math. They don't want to do the math. And so if we get them prepared in principles, I think we're going to see larger numbers, and larger numbers of overall, and larger numbers of women going into economics as a major.
But Alex has brought up the issue that he doesn't have time to teach math. Justin has mentioned that he's not going to write the woes of the high school system. So what do we do when we land students who are math-phobic? So does mathphobia prevent you from getting an education in economics? Should we dismiss those people? Should we send them to a boot camp so they came back like angels of math, and they know everything that they need to know? So what do we do with students who are not fans of math but are students of economics?
You're asking me?
I want to hear from the three of them.
Yeah.
Let's see, Justin probably has something in mind.
You said something, Irene, that was so striking, I wrote it down to make sure I got it right. You said, the biggest problem is the lack of math preparation of our kids. And then you used that statement, which I think is true, as an argument for we should teach economics using math. That strikes me as exactly the wrong implication. Mm-hmm. If the students don't have the skills to do mathematical economics, we should teach them using the sets of skills that they have.
Yeah, that's exactly what I said.
But how?
Yes, we have conflict.
How does it follow that we should teach them using skills they don't have? If you and I got to redesign the American high school mathematical curriculum, you and I would do the same thing, but I'm taking it as given they're walking in with very few skills. And it strikes me, and I am an economic evangelist, and so every single kid who walks in and gets scared by the math and decides to drop economics, that's a lost soul.
Yeah.
That's someone we could have saved. I don't want to see any of them walk out.
Yes. I am in complete agreement with you on that. I don't disagree at all. Where I teach at GW, people, we are located 2 blocks from the White House. People come to GW because they want to become president of the United States. In fact, I mean it. The first class.
If only.
The first. We're working on it, and we are teaching them the math so they understand why you can't have a 6% growth rate. Okay. So yeah, I mean, so I'm seeing students. I mean, the first day of class, I walked into GW, my very first class, a student comes up to me after the first day and says, "Hi, Professor Foster, I'm Brooks Boron, and one day I'm going to be president of the United States." This semester, I had a student who walked up to me and said, "I want to be Janet Yellen." Oh my God, that really warmed my heart. I mean, notice the guy did not say, for you ladies who are going to be on the economic empowerment panel, he didn't say, "I want to be Fed chair." He said, "I want to be Janet Yellen." Yes. So anyway,
That's pretty creepy.
that's pretty amazing. Anyway, so yes, I get you immediately. I understand. So at GW, we have been collecting data on students since 2011. We decided that we did not want to lose the mathematics and the principles of economics course. So what we decided was that we saw that we had strong students and we saw that we had very weak students. We saw that students who were marginal, that we could help in the first few weeks of class. So one of the first things that we did some testing. We started doing what we called a math assessment. The first week they came in, we would give them this math test. It was 20 questions, very simple questions, just based on Algebra 1. We did not ask them anything extraneous besides what we would expect them to know for a Principles of Economics class. Do you know how to do a percentage change so that they could do something like elasticity? Do you know how to calculate the area of a triangle so they could do consumer surplus? So we didn't ask them any deliberately hard questions. In fact, we only asked them the stuff that they would need for a Principles of Econ class. And we gave them very simple numbers. And then to test their numeracy, we actually had them do it without a calculator. We gave them 45 minutes, 20 questions. We asked them to come up with a straight line, or gave them a straight line and said, what is the equation of the straight line, just to see where they were. And we found that on that test, about 70% of our students couldn't even get a 60% on that test. So we were shocked. We had generally talked about students being weak in math, and we were just shocked. And we said, okay, we do have a problem. We were right. It's not just our bias that we think we're all so much better at math than they are. They actually don't know. So after that, we decided we would do the testing every semester in every one of our principles classes. And then we thought, what are we going to say to the students? So we said, let's try and give them review sessions. Very quickly, like in the first 3 weeks of classes, let's make this a big percentage of their grade. So we said, okay, this math test is going to be 10% of your course grade. We'll give it to you in the first week of classes. Second week, we'll give you a review. We expect everybody to score at least an 80% on this test to show mastery. We know that immediately, about 50% of the class was able to get through the test immediately, because we contact them at the beginning of August and say, 1 month before they come to campus, we contact them. We send them the previous year's math assessment, and we say, guys, we're going to expect you to know this for class, so please come in prepared, because first week of class, we're going to have this math test, and it's 10% of your course grade. So about 50% of the students will come in, they'll get that 80%, and they're good, they're fine, they're done. Then we have the other 50% that we need to worry about. So the very first week of class, we give the test. The second week, all the guys who didn't get the 80%, we have a review session for them. We have a few TAs who hold a review session, show them, how do you do the percentage change, how do you do X, Y, and Z that they missed, figure out the equation for the straight line. And then the third week, we give them the test again. Again, a similar test, similar questions. And then by that time, another 30% have got it. So all they needed was just a little bit of help, a little bit of push, and then by the second week, 80% of the students are done. And then we have that 20%. That's the really weak group. So the 20%, the fourth week of classes, we have yet another review session. And then we give them, in the fifth week of class, another test. And then by that time, of that 20%, only a small group passes. That is our weakest group. We have done this now since 2011. We do it semester after semester, and every year, consistently, what we see is, out of that group of 1,500 students that come in to take Principles of Economics every fall, we have about 11 to 13% of the students who just cannot pass that math test despite any help that we give them in the first 3 weeks. So what options did we have for that 11 to 13%? We would just tell them, guys, you need to go to somewhere else, maybe to your local community college, or maybe Kumon Math, somewhere you need to relearn your Algebra 1. We want you in this class. Please come back and join the class, but know that you've got to know the stuff in order to be in this class. And we did that for a couple of years, and then one of my colleagues...
so many lost souls here.
No, that's exactly right. So that's what one of my colleagues said. He said, oh my God, so many lost souls. What about all these people who are going to be president? We can't just let them go, you know? So
Well, we only need one, and hopefully qualified.
Yeah.
So what I'm hearing is that your school, you try to save the lost souls by training them and giving them remedial training. Justin is talking about adapting to the skills that they have and building on what they have. What about you, Alex? Where do you stand on this?
I've kind of changed my tack. So just a bit earlier, I said one of the biggest downsides of not teaching math and principles is we're misleading students. And then I thought about my experience as an 18-year-old. I didn't think I was good at math. I'm not great, but I'm better than I thought I was. I took economics and I just thought it was like, you get the impression it's like sociology applied to the economy. So I went into the stream, and then it got math heavy, tough. And I'm not smart enough to ignore sunk costs, so I stuck in there and just made myself learn math. And I found out, it's actually interesting, elegant language. So maybe it's good we mislead our students, that they come in a principles class and they think there's no math involved, and we're just essentially kicking them in the deep end. And they've picked a major. They're like most of us. They don't ignore sunk costs, and then they're forced to learn math. And it gets back to, I think it's I agree, a lot of students have misconceptions that they don't understand math, which isn't true. So maybe misleading them, kicking them into the program is maybe a good thing. They'll put in the time and effort to actually learn math.
So what I'm hearing is that 4 of us here, 3 of us, I don't know if about you, Irene, you haven't revealed yourself, but we didn't like math as college undergraduates. I confess to having a terrible time doing math as a college undergraduate in Spain. By my 4th year, we're taking topology classes in the econ program. So why would you need topology in an undergraduate degree? Yeah. But it was only when in graduate school things were put in context. I was like, so this is this is why I study all these things. But I'm not so sure that that's necessarily the path forward for many students who will not go into graduate school themselves. So another distinction that I'm hearing here is between, again, going back to that notion of formal reasoning and quantitative reasoning, those numeracy skills that have to do with statistical thinking. So right now, we don't have any place in the curriculum. You see the textbooks, the average textbook in introductory economics, it makes no distinction between mathematics and statistics. We don't talk about correlations, we don't talk about trends, we don't talk about seasonality, none of that stuff comes out. Probability is nowhere in the introductory textbook. But when you see what the profession is doing, most of the research that comes out these days is empirical in nature. So we make arguments, and this is an argument that I made in other places. Economics is a social science, unlike sociology in that we use quantitative evidence to back our claims. Yeah. Unlike political science, we control for a variety of aspects when we try to make an argument about a social event. So how are we to convey to our students, is there room in the introductory economics curriculum to bring to the students the fact, not the disciple, but the fact that economics is an applied discipline, and that most of what we're doing these days in research is applied in nature? Justin?
So I agree with that. Our students are going to grow up in a statistical world to a degree to which none of us can imagine. None of us did, because everything's being measured. And so every single job, many important management functions are going to take an enormous flow of data and turn it into insight. And that actually gives a new role for economics. So the old role for economic theory was, we don't know a bunch of facts about the world, so we're going to make some assumptions and talk about theory and use a theory to fill in for the missing facts. Our students are going to grow up the opposite way. We have too many facts, we need some way of making sense of them. And so this is the idea of using simple economics as a framework for organizing the tidal wave of facts. So this quantitative reasoning, I think, is really important. Again, I want to come back to do the math, in this case statistics, but do it in English. So it turns, if you talk to any freshman, I've run this experiment, and you say, economists have discovered that people with a degree, with a college degree, have higher wages than people without. You say, why? And they'll immediately say, well, maybe they learn more and that's helpful. And then they'll say, but maybe smarter kids go to college. right? That's the reverse causation story or the omitted variable story. They're not going to call it that, right? And so they have this great intuitive notion. They're actually very good intuitive statisticians. But if instead I wrote down a wage equation that said W equals alpha plus beta times years of education plus the error term, not one of them would put up their hand and say, but the covariance of X and epsilon is non-zero, violating the assumptions. And the problem is when we have them do mathematical statistics and we teach it that way, they'll actually go and run a wage equation like that without thinking about the possibility of omitted variables.
Yeah.
When we teach them in math, they make these assumptions that they would never make when we're talking in English. So this is it, you know, when we're in English, I think they're actually much better intuitive statisticians than when we force them through the Greek letters. And so that's, and we can do that in principles as well, because anytime we're teaching something, we should be in touch with the evidence. Yeah. Right, so why do we have inequality? Well, one is some people have an education, some people don't. So we do talk about that in my class. And then we talk about the possibility that there are other explanations. And I think it's a very natural part of like how we can teach. It's the connection between theory and data.
So in the test that you give your students at George Washington, are there any questions about probability thinking or making inferences, or you mentioned that it's algebra 1 and slopes and things like that. Is there any on any topics on quantitative reasoning?
Not really, but I'll get back to that. So just for the principles class, we don't do it. I'm in agreement with Justin on the importance of doing the statistics, so introducing some statistics in micro and macro. In fact, I think macro, I always tell my students, you have to look at the data in order to understand what's going on. You have to look at it historically, you have to look at it across countries to understand really what's happening, why policies work in some countries and the same policy doesn't work in another one. So I think it's really important. We cover things like, we talk about, okay, median wage went up. That was an important thing. It was in the newspapers. So students are interested. Why is this so interesting? Well, it hasn't gone up for a long time. So we discuss all of that, and then we talk about why median? What is a median? And then, why not a mean? Why not a mode? And then, so we do that, the statistics, sort of slip it in behind the news, which is very interesting. By then, you've got them hooked, and then they want to know. And then you could use a simple illustrative example. Yeah.
What about you, Alex? What about the role of the statistics and quantitative reasoning in the
I
economics?
think in principles and in the undergrad program in general, we should emphasize statistics. From my students I teach, it's a Frankenstein of a course. It's intro to econometrics plus math applied to economics. We're getting rid of it, thankfully, because it's a nightmare to teach, and my students hate it. But it's kind of interesting because you see stats and math side by side, and I really think they're actually a lot weaker in stats than math. Because K-12 system, they kind of speak, they're not great, but they speak the language. They kind of get it because they've been seeing it 13 years. But stats, it's completely new to them. And for me, they've already taken one prereq in stats. But I think they're a lot weaker there. And if we look at our undergrad majors, those that go into graduate school, obviously they need to be strong in statistics, especially the intuition. But even the ones that don't go to graduate school. So employers now, what they expect from econ graduate is they want a quant. I worked for 8 years before I came to academia, and I never took one derivative, but it was a lot of just essentially taking a massive data set and telling an elegant story. So I think it's really important to be teaching that. And I think, like Just said, it's quite easy to teach in principles. I know I've said we don't have enough time to teach what we already have, but it's fairly easy to just put here and there, like, an average wage, or people with higher education on average have higher wages and get their feedback. It's fairly easy to teach that in principles. And I think later on in senior undergraduate, there's a bigger problem with no statistical intuition versus math.
So here's, I think, it's a huge irony alert, right? So professionally, economists will be hired to manipulate large data sets and find patterns in data. We don't really use the math per se that we supposedly learn in graduate programs, yet our curriculum does not make use of statistics, right? So all majors in economics, I'm sure they have a statistics requirement. One of the core courses is a statistics class, maybe an econometrics class, but I'll be curious to see a show of hands if statistics is a prerequisite to any economics class. So you cannot take intermediate macro, for example, if you haven't completed a statistics course. So the thing that we use the most is the thing that is most invisible in the undergraduate curriculum somehow. So I think we're setting ourselves, or I think this is a great opportunity for a publisher to come up with a new book that will fill this void, because there's clearly a gap.